Well, do you remember back in 2020 when Tesla made all those wild promises about a revolutionary new battery, a dry electrode process that could slash the costs and change how batteries are made? The entire industry, full of experts, basically said it's impossible to scale that up. Well, in a recent shareholder update, Tesla quietly confirmed a breakthrough that everyone's been waiting for. This isn't just a small improvement, it's the fulfillment of a promise that completely changes the equation for electric cars. This is Dave Takes It On. I'm Dave, and I'll reveal just what has happened, what it means for the EV drivers. But first, just click on that subscribe button, please. Well, let's rewind to September 2020. Tesla hosted its Battery Day, and for battery nerds, this was our World Cup final. On stage, Elon Musk didn't just announce a new battery, he unveiled a complete reinvention of the manufacturing process. The star of the show was the 4680 cell, named for its 46mm diameter and 80mm height. But the size was just the start. The real bombshell was the method, the dry battery electrode DBE process. For decades, making batteries has been a messy, expensive and slow wet process. Imagine you're making a cake batter. You mix active materials like nickel with binders and a toxic, costly solvent, creating a thick slurry. This goo is then painted onto metal foil and baked in massive, time-consuming, energy-guzzling drying ovens, each as long as a football field. This step alone accounts for a huge chunk of the cost and energy used to make a battery. Time is money. Well, Tesla's promise, which they picked up after acquiring a company called Maxwell Technologies, was to get rid of that entire messy step. The dry process takes raw electrode powders, mixes them with a special binder, compresses them directly onto the foil. No toxic solvents, no slurry, most importantly, no giant ovens. The promises were audacious. Tesla claimed this new process was a key towards slashing battery costs by over 50%, shrinking the factory footprint and boosting vehicle range. It was the technology that would unlock a truly affordable $25,000 Tesla, a worldwide fleet of robotaxis, and a sustainable energy future. But the industry disagreed. Experts pointed out that while the dry process worked in a lab, scaling it for cars was a monumental challenge. For years, it seems the critics were right. The promises of Battery Day faded into what many dismissed as just one more Elon hype. So why do what was impossible in the first place? Well, the answer was that every single breakthrough in battery chemistry that made it to mass production involved reducing the energy density. Yeah, sure, sodium, cheap iron battery, that is really cheap and easy to make, but it has an appalling energy density. Plain logic says, why not just improve the production method of current high energy dense NMC or aluminium ion batteries? Or maybe even higher. Tesla stated that the 4680 breakthrough leads the way to not 200 watt-hours per kilogram or even 3, but actually the first 1000 watt-hour per kilogram battery, beating solid state to the punch at a fraction of the cost. That way you could use fewer batteries in each EV, making them lighter and save a shed load of money on each battery. There's no need to spend billions exploring new chemistries if you can make the existing batteries more powerful and cheaper. As ever, to Tesla, this was a simple challenge, do the impossible. And while it has taken its time, 5 years to be precise, it's been done. Dry battery electrodes are finally in mass production, and the impact is staggering. So how did Tesla achieve this impossible task? Well, the first challenge is just mixing the powder. An engineer close to the process described how a bucket of powder can have very different properties from the first scoop to the last. Getting a perfectly uniform mix without a liquid to help is incredibly difficult. An uneven mix means a totally useless electrode. While Tesla managed to solve this for the anode, the negative side of the battery, the cathode was a different beast entirely. And this is where the impossible label really came from. The cathode is the positive side, made of hard, brittle metal crystals like nickel. One expert compared the challenge to compressing fine gravel into a smooth mirror-like surface. The material is not forgiving. The old wet slurry process helps cushion these delicate particles, but in a dry process, the immense pressure needed to form the electrode sheet can actually shatter them, destroying their ability to store energy. Well, this exact problem was Tesla's biggest roadblock for years. The dry cathode process proved far more difficult to industrialize than expected. The production lines would frequently damage the sensitive material or the machinery itself. One engineer noted a single failure in the high-pressure rolling press could cause 45 days of downtime. Well, the industry watched as Tesla struggled. The company was forced to adopt a hybrid approach, using the new dry process for the anode, but falling back to the old wet process for the cathode. Well, this let them produce some 4680 cells, mainly for Cybertruck, but it meant they couldn't get the full cost and efficiency savings promised at Battery Day. Skepticism blossomed, and reports even surfaced that Tesla was considering abandoning the effort entirely. The dream of a fully dry processed battery seemed to be slipping away. Then the news finally dropped. In its quarterly update at the beginning of 2026, Tesla confirmed it was now producing 4680 cells, where both the anode and the incredibly difficult cathode were made using the dry electrode process, and it was being done at Gigafactory, Giga Texas. Elon Musk himself called the achievements incredibly difficult and a major breakthrough in lithium battery production technology. So, how did they finally crack that code? Well, the secret remains a secret, but is believed to be a sophisticated multi-step process that Tesla has now perfected, making it very difficult for competitors to copy. Tesla reportedly developed low-shear techniques to gently combine the fragile cathode particles with a special PTFE binder, preserving their structure and avoiding the gravel crushing problem. Second, it's a process called fabulation. As the powder is mixed, the binder stretches into a microscopic web-like net. This net physically traps the battery materials, creating a strong self-supporting film of dry powder without any liquid solvent. Third is calendaring. This is the high-pressure rolling step that was so difficult before. The dry web-like film is fed through the rollers and compressed into a smooth, dense sheet. Because the particles are protected by the fibrillated binder, they aren't crushed. The result of this fully dry process are a huge step towards delivering on the original promises. These new 4680 cells represent a major leap in energy density and power output. Critically, the longevity is also expected to see a massive improvement. Because the dry process is gentler on the materials, the resulting battery should withstand far more charge cycles than those made with the damaging wet slurry and high heat method. Tesla hasn't just made it work, they've made it better. Well, a technical achievement in a factory is one thing, but what does it actually mean for drivers and the future of EVs? Well, this breakthrough isn't just about a better battery, it's a manufacturing revolution. Well, let's start with the cost. By eliminating toxic solvents, football field-sized ovens and the energy-intensive drying process, Tesla is set to slash manufacturing costs. This is a huge step forward towards the machine that builds the machine innovation that Tesla always talks about. The factory itself becomes the product. The new process is incredibly that much smaller, so dramatically lowers the capital cost of building new gigafactories and allows for much faster scaling. This single breakthrough, smaller, quicker factories, puts Tesla on a clear path to its stated goal: price. Making them in-house at incredible speed makes these batteries really cheap, but they aren't just as powerful, if not more so, making its in-house 4680 cell the lowest cost battery the company uses. In fact, the lowest cost batteries anywhere in the world. So what does this enable? Well, first, a much more affordable Model Y, which was designed from scratch to use the structural battery pack, where the battery pack is a structural element of the EV. Tesla's now confirmed it has begun putting these new 4680 cells into certain Model Ys. For now, the company is framing this as a strategic move to guard against supply chain issues and tariffs. But the implications are clear. The technology to produce a significantly cheaper Model Y now exists. Well, as production ramps up, those cost savings can be passed on to the consumer, pushing the world's most popular EV into an even more accessible price range. Second, it makes the robocab future a reality. The entire concept of a low-cost autonomous vehicle depends on an extremely durable low-cost battery. Vehicle in service 24/7 needs a battery that can withstand thousands of charge cycles. NMC batteries provide that, but now so much cheaper. With its improved durability, the 4680 cell is the first battery that truly fits the bill. But hang on, what about the lithium? Surely it's expensive and comes from China. That means tariffs, but of course not. Tesla's always several steps ahead of everyone else. In 2025, a 1 billion, 1,200 acre lithium hydroxide processing refinery near Corpus Christi in Texas came online. Lithium is one of the most abundant materials on the planet. It was the refining that was expensive and previously exclusively controlled by China. Not anymore. Tesla now extracts its own lithium from the ground surrounding the processing plant, which uses a brand new technique that is far more efficient, cheaper and cleaner. Its waste material is not toxic. In fact, it's actually a neutral sand-like material that has a use in the building construction industry. A useful product. So this reduces Tesla's dependence on China or any other sources. The impact extends even further. The Cybertruck, which already uses 4680 cells, will benefit from the increased production speed. Tesla's Semi and even the Optimus robot are slated to use this same cheaper technology. This single breakthrough in battery manufacturing underpins the viability of Tesla's entire future product roadmap. Well, please just take a moment to consider the work that goes into making these videos. If you learn from them or enjoy them, please have a look at joining our growing band of Titans. That's members so-called because they support Takes It On Titans. Membership starts from just about £2 a month, cheaper than a single Costa or Starbucks special. And the benefits include early access to videos, members-only videos, including bloopers, regular member meetups where you can meet me face-to-face. Buy me a coffee, maybe tell me why I'm wrong. Details for that down below. Well, it's taken from 2020 through to today to make this happen, but now it is an absolute game changer. Tesla took a massive gamble on a technology the rest of the industry and the experts all called impossible. And now that bet is finally paying off. But what do you think? Is this the final piece of the puzzle for mass EV adoption? Will we see sub $30,000, £30,000 Teslas anytime soon? Let me know your predictions in the comments down below. Well, Tesla has achieved something really remarkable. It has solved the great challenge of the dry cathode and industrialized a battery manufacturing process that is cheaper, faster, more efficient. It's a technical success born from relentless engineering and the refusal to take the easy route. While the current rollout in the Model Y is driven by pragmatic supply chain strategy, the technology itself is revolutionary. It sets the stage for the more affordable electric cars, longer-lasting batteries, and the next generation of Tesla products. The impossible has happened, and for the electric vehicle revolution, this really is just the beginning. I'll see you on the next video. I'm Dave.